similar triangle proofs. It's just a proof is a detailed explanation of why something is true. So with a proof, we're explaining that we have statements and we're telling why those things are true with the reasons. So common reasons for proofs are the given, reflexive property when a figure is congruent to itself. And remember that can be with sides when two sides are shared, and it can be with angles. So we can have reflexive sides with congruent triangles, we can have reflexive angles with similar triangles. There can also be special angle pairs, which are the alternate interior. We don't really see alternate exterior too much. I don't know if there's any alternate exterior on this. Corresponding and vertical. So those are our most common reasons. And remember, to prove a similar triangle proof, there are only three postulates for these. So you have SSS similarity, SAS similarity, and angle-angle similarity. And on these, you do not have to mark the pictures like you do on a congruent triangle. But it does tell us that on the first one it says AB is AB is proportional to DE, so these go together. BC is proportional to EF, and AC is proportional to DF. And I didn't write them on the line, the little tick marks on the line, because they're not congruent. I just do that to show that I have three proportional sides. That is given. If you have three sets of proportional sides, how can you prove the two triangles are similar? Side similarity. See, not bad.
Why are all these given?
It's not hard.
Sometimes they won't be given. Okay, so on the next one it says JK is proportional to JM and LJ is proportional to JN. So I know I have two sets of proportional sides. So what's the only thing it could possibly be?
Side.
If you only have two, it can only be side angle side similarity.
Yeah.
And then it says we are given angle KJL is congruent to angle MJL. Those are the same angles, but it was given. If they weren't given, we know those angles are the same because of reflexive. Okay, on number 1 on page 32. So it says angle G is congruent to angle J, so we've already got one angle. So we know it's not going to be side, it's either going to be side, or angle. And then it says GH is proportional to JK, GI is proportional to JL. That is side, angle, side, and the other two things are given.
It's simple, man.
Told you some of the triangle proofs are pretty simple compared to congruent triangle proofs.
Oh, we gotta put a little arrow on the thing. Yeah. Yes.
Okay, so on number 2 it says we're given PQ is parallel to ST. We're given that. So are we given any sides are proportional? No, right? So if we don't have any sides, what does the end have to be? Angle. Because we're not given any sides proportional.
And
So it says the second statement is RPQ is congruent to RTS. So RPQ congruent to what is it? God, I cannot.
Angle P, angle T.
Angle P and angle T, thank you, because we're
And
can't do math today. Can't do work. So those are not vertical, they're not corresponding, they are alternate interior angles.
Yeah.
And then it says PRQ is congruent to SRT. So the angles those are vertical angles.
That's what you.
And then we do know now that we do have two angles, so those are proven by angle similarity. Okay. Now it's given to me that AB is proportional to AE, AC is proportional to AD. I know that given. I'm only given two sides. So what is it gonna have to be? If you're only given two sides. Side, angle, side.
Yeah, that's it.
And then it says BAC is congruent to EAD. It's the same exact angle, right?
Right.
If they're the same exact angle, that's the reflexive property.
We trying to lose on our own.
I mean, if you want to, they're really not that bad. They're pretty much all exactly the same.
I hate.
We like change it up and do like, we're like, you play like a game or something with the practice.
Trash football.
Dude, not every time I say game, I say trash ball. It's like some kind of game.
I switched it up yesterday and let y'all work in partners, so I mean,
I know, but
I'm
like,
trying.
I appreciate
slowly,
that.
surely.
I appreciate that.
We may play trash ball. I don't really know. I like playing trash ball.
We play right now.
I'm a hooper. Look,
You need to learn something.
I mean, obviously I like trash ball. I have a special trash can for trash ball.
but in a special ball for trash ball.
I actually used to, like, they made it. One of my kids made it. It's just a piece of paper wrapped in a bunch of.
Oh, we could do that. Get some paper. I got some
I need
paper.
to get a basketball, but I never think of it.
You need to get one of the, like, skills hoops.
Yes,
Mini hoops.
Okay. It's like a little miniature hoops that go over a door. I have
Put
one.
our own goals.
It just doesn't fit on that door.
really
On
don't.
that door.
You can sit on that door. I'd say, you can get dunked on. Tony, you
Y'all go
want-
ahead
you want
and
this one?
try all of those on page 33. Try those real quick.
Where?
Okay. So again, just to reiterate what I just did on that problem, you want to, I did a highlight method, highlight, corresponding parts, then set up the ratios like I did in the blue. With the one that is perfect and was given to you, the 40/16, set those equal to the two other ratios and you can solve for X and Y. So if I'm looking at number 2, I want to do my highlighting. So DE is proportional to what side?
HJ.
HJ. So I can set up a ratio with that. I'm going left to right, so 9/15. Then my next one, I'm gonna go EF. Goes with
14,
JG, so it will be 14/Y. And then the last one, DF and GH. So 12/X.
Oh, we get decimal.
Okay, so with similar triangles, you're probably gonna get some decimals with these problems, just so you know, decimals are okay with these. So I'm gonna take that 9/15, I'm gonna reduce it, because I like to reduce them. 9/15, what's that reduced to? 3/5. So I'm gonna use the reduced one, because it gives me smaller numbers. So I have 3/5 equals 14/Y. And 3/5 equals 12/X. And then cross multiply. So 3 times Y is 3Y. And what's 14 times 5?
7.
So 3Y equals 70. Divided by 3, you are going to get a decimal.
23.
And Y equals 23 0.3. Okay, you're gonna do the same with x. Cross multiply 3 times x is 3x. 5 times 12, what's that give you? 60. Then divide by 3, and x does equal 12. Okay, so on the next one, we do have an x plus 5 in there. It's really not that bad. It's not that much more. Just gotta distribute once. So what I'm gonna do, I'm gonna look at my sides that I have. So QR corresponds with TU. So I'm gonna write my ratio with that. So 24 over x plus 5. Then I only have one other side, so I'm going to look at that side. If you want to, you can look at all of these sides and highlight through. But I know I'm going to be looking at RS. RS goes with UB. So my ratio there is 54 over 36. And then my other side's QS goes with BT or TD. We don't really need the blue side, but it is nice to know that those are corresponding. So now, again, this is one where I would not want to keep the big numbers, the 54 over 36, if I didn't have to. I'm going to show you why. I'm going to show you how to do it with that one right there and with a simplified one. So I keep that 24 over x plus 5, but I can reduce that 54 over 36, and that reduces to 3 over 2. I'd much rather work with 3 and 2 than I would with 54 and 36. So I'm going to focus on the blue one right now because in my opinion, that's the way to go. But if you do it the other way, that's perfectly fine too. So cross multiply, I'll have 3 times all of x plus 5 equals 2 times 24. So I have 3 times a binomial. I have to take that 3 to both things in the binomial. I have to distribute. So I have 3 times x is 3x. And then what's 3 times 5? 15. And then 2 times 24 is 48. So now I can do inverse operations and solve for x. So I need to move that 15 over, so I'm going to subtract 15 from both sides. So I have 3x equals 48 minus 15, which is 33. Then divide by 3. You have x equals 11. Okay. So that's the way I would say to do it. If you forgot to reduce, I'm about to show you what you would have got over here. You're going to get x equals 11, but it's going to look a lot different.
Oh, yeah.
So again, you get to the same answer, it's just you have way bigger numbers. So you got like 270, 864 instead of 15 and 48. So just know if your math is not exactly the same as mine, it's because you didn't reduce or I didn't reduce. But as long as we get to the same x, that is perfectly okay. Okay, so when you have the overlapping triangles with the baby and the mommy, remember to separate them out like that, or you can leave them the same. I like to separate them out with the two pictures. Remember you have to combine the 20 and the 8 to get 28 for AB. Then I highlight, then I set up my ratio over to the right. And again, I did left over right triangle. Reduce that 20 over 28 to 5 over 7, then cross multiply. So 5 times 2x is 10x. 5 times 3 is 15. 7 times 15 is 105.
Oh, I think I got the next one too. Oh.
Okay, so subtract 15 from both sides. And you will have 10x equals 90. And what's 90 divided by 10?
I did wrong.
I added 15 to the next.
And you get x equals 9. So no ratio for those because there's no numbers on them. Then NP goes with RP. So I can write a ratio for that. So I'll have x plus 8 over 3x minus 9, because I'm going left to right. And then the last one, MP, goes with PQ. So 24 over 28. Okay, and I reduced my fraction, 24 over 28, to 6 over 7. And now I'm going to cross multiply. So, doesn't really matter which one you do first. I'm going to do 6 times 3x minus 9 first, just because I can see that 6 times 3 is going to give me a bigger x value than 7 times x. That's just how my brain works. I like to have biggest x value on the left. So then I'll have 6 times 3x minus 9 equals 7 times x plus 8. So I have to distribute on both sides. So 6 times 3x, 18x. 6 times negative 9, negative 54. 7 times x is 7x. And 7 times 8 is 56. Okay, inverse operations, I'm going to do them all at one time. So move the 7x over. And move the 54 to the right.
Well, hold on. Hold on, where did it start?
Let's see.
Rosses.
Okay, so 18x minus 7x is 11x. And 56 plus 54 is 110.
I got a question.
And divide by the 11, and you have x equals what? 10. On number 6, with my highlighting method, I know BC corresponds to FG. And I know CD goes with EG. And BD goes with FE. So, based off of that, you've got to set up your ratios. I always go left to right, so if you want to do it like mine, I go left to right. So 39 over 4x plus 2, 42 over 5x minus 2. So go ahead and set that one up. And that's how it should look. So I have yellow over yellow, blue over blue. So that one's already set up. And then you can't simplify anything, so all you gotta do is just cross multiply.
It says scale factor.
Yeah.
Okay.
It's 8, 4.4.
What'd you get from number 6?
You told, I put, the one you told me for, what you put me?
I got 8.
35 over 40.
35 over 2x plus 2.
6.
That was the other way I told you to do it.
Yeah, I don't like.
So you could do 35 over 2x plus 2 equals 40 over 3x.
Minus 7.
So just, okay, so went ahead and distributed that 39. Then distribute the 42. And then you're going to do inverse operations. So subtract 168x
I'm confused.
and add 78. What y'all get? 6. X equals 6.
13.
Okay, so on number 8, I'm just going to highlight the triangles the way that they already are.
Did you get a decimal? Did you get a decimal? Not 4.4.
So I'm just going to look at the sides that I know I have. So I know I have YZ. YZ goes with RT. So those two sides are proportional. And then I have SZ goes with ST. So that whole thing. So when they're overlapping like that, it can get kind of confusing. But I need to know what SZ is. How can I find what SZ is? 40 minus 5, and that gives you
I was that.
35. So, with that, you can now set up your ratio. 35 over 40, so I'm going baby over mama.
Baby on baby.
And then 2x plus 2 over 3x minus 7. So that's the ratio you should have. Again, you can reduce that 35 over 40 to 7 over 8. And then cross multiply. And go from there. So I'm going to come back to that in a little bit because I want y'all to work through that. I want y'all to practice the algebra. And I want you to practice on number 9 too. So I'm going to help you with set up number 9, and then you're going to finish both of those. So looking at this, I can follow my similarity statement, or I can just look at, I know I have DE on this triangle. So DE goes with GE. The other side I have is EC. EC goes with FE. And then my other two sides go together. So DC with FG. But I only need the yellow and the pink. So again, I set it up left to right. So I want you to set that up left to right this time. So yellow over yellow, pink over pink. And then solve these two problems.
Nah, you got
Okay, so number 8 you should have got 13. Number 9 you should have got 8.
See, it only took us 20 minutes.
Okay, so with a scale factor of 3 to 5, okay, it wants you to find the perimeter of triangle PQR. So first we need to find the perimeter of this triangle. So to find the perimeter, we add up all the sides, right? Remember perimeter, we've been doing that since like 3rd grade. Okay, so 6 plus 15 plus
34.
12. Alright, 6 plus 15 plus 12.
3 to
It's
5.
33.
What? No, it's not.
6 plus 15 plus 12 is 33.
6 plus 12. 6 plus 15 is 21. Which would make that, that make that 33 there.
Yeah, get it right, boy. Okay, so the perimeter of this one is 33, and we want to know the perimeter of the big one.
55.
So we can set up a ratio, right? 33 over P as perimeters. 33 over P. Small one to big one. And then what's the ratio with the scale factor? It's 3 over 5. Because that has a 3 to 5 ratio. It says scale factor, but that's still ratio. So what we're going to do with that, then you're just going to cross multiply. So find the perimeter, set up a ratio with the perimeters, and then set it equal to the ratio. So 3P equals 33 times 5, which is 165.
Which equals 55.
Then divide by 3. And the perimeter of triangle PQR.
I did it a different way.
Still got the right answer.
I did it in my head. I just did 33 divided by 3. They got 11 divided by 5. I've never done it before. Just thinking.
You just do math in your head. It's the same process, you just do it in your head. And so the perimeter of PQR is 55.
Yes.
after taking the PSAT? Oh.
I was in it. I mean, I couldn't see what. I was thinking.
Okay, so I want y'all to work on page 35, 36, and 37. I don't know how I can make that a game, I'm sorry, because I need everybody to do it right.
Well, Bob was practicing.